Hi, everyone. I wanted to take a little bit of time this morning to record a video walking through our notebook on data wrangling and tidy data. In particular, this notebook shows us how to deal with messy data and when our data has some flaws in it, which is going to happen. In fact, most of the data that we work with in the real world is going to have problems. This notebook is designed to expose us to some of the most common problems as well as some fixes for those problems. So how do we deal with the most common problems that data can come along with? You won't be certainly an expert in data wrangling after just this video, but again, you'll have some of the most commonly used tools to solve some of those most common problems. So let's go. Like I said, we're just going to walk through this notebook. It's the notebook that I pre-built for you all. Um, so we're going to start by running this command rm list equals ls. If you remember, that takes R's warehouse, the global environment, and just clears it out. So if you're like me, you like a clean working space. We're also going to load the tidyverse library. I'm going to try to zoom in here. I'm not sure how easy it's going to be to read this on a screen. So we'll load the tidyverse library. That's a meta library. It contains lots of the most commonly used packages. We'll load tidy models, which we installed last time when we met in class talking about data visualization. We'll also load this library called random names. So random names you'll see being used here. It's just to generate random names of people in the data that we're going to work with. In order to load the library and run this notebook, you're going to have to install the random names package. As a reminder, you can just get rid of this comment, run that line of code with Control and Enter, to install the package, then recomment it so that you're not installing this package every time you run this notebook. So I'm going to go ahead and load the random names library. And I'm going to load Cable Extra, which we've seen is a library that just helps us draw nice tables in HTML output. I'm also going to load some data from the web. This is data from IKEA. We're going to use just part of that data. We're going to generate some fake data for this notebook. I'm going to set a seed. That way, when you run this notebook, you'll get the same results as I do. And I'm going to build a bunch of data sets. So I'm going to kind of cruise through here because none of the code is very important. All I want to do is build some data for us to work with. Okay, so we've got a bunch of data now in our global warehouse. We've got clients, historical purchases, we've got IKEA, orders, products, purchase history, and then some other values. So we've got items, dupe, and then num rows. But we don't need all of these things, so I'm going to remove most of them. A few of you have asked about, can I remove just a few items instead of all of the items in my global environment? And what I did is I showed you how to remove one item at a time just by putting the object name inside the RM function. Sometimes you want to remove most of your items and leave just some of them. That's the case here. So I'm going to use, instead of removing everything, so that's what ls says, I'm going to remove the difference. So set diff is set difference between everything in my global environment and these things that I want to keep. So I want to keep clients, orders, products, purchase history, and historical purchases. So let's just run that, and we should see a nice clean working space with just a few tables that we're interested in working with. So objectives for this notebook. Again, we're going to give an overview of the most common problems that data come with and some of the methods for dealing with those issues. So the problems that we're going to find are really common are inconsistent data recording issues, so spelling mistakes, capitalization mistakes, things like that. Unexpected data types. So maybe we expect something to be a numeric variable, but it's being read in as a string or a character for some reason. We may have multivariable columns, so a column that stores not just one variable, but two or more. We'll talk about wide format and long format data. It's going to be useful to be able to pivot between these two. In particular, if you're used to dealing with economic data, GDP, stock data, a lot of the time that data comes in wide format. We'll see what that looks like later on in this notebook. And a super common, it's not a problem, but it's a common issue that we'll have to deal with, is that we have data spread across multiple tables. And we really want a centralized location for our data. So we need to kind of collect data from multiple tables and put it together into one data frame that's nice to work with. Okay, so again, here's our first challenge that we're going to deal with. We'll take a look at the products data frame, and we're going to see that it has inconsistent data recording problems with it. So we'll see that. We have tables and desks cost $125, outdoor furniture $675, beds, nursery furniture, sideboards, buffets, console tables. Outdoor furniture is listed again. You'll notice it's separate here because I have a capital F on furniture and a lowercase f on furniture, so there's some inconsistency there. And then I have nursery furniture showing up again with a couple of spelling mistakes. So nursery is spelled wrong and furniture is spelled wrong, in addition to the F on furniture is being capitalized here. One nice thing, though, is if I look at both of these categories, so outdoor furniture originally was spelled correctly and capitalized. Only the first word was capitalized. Outdoor furniture costs $675 per unit. And down here in this second occurrence, it also costs that. So there's consistency in that price column. And the same for nursery furniture, actually. Both instances here are at $475. So that's convenient for us. If we didn't have consistency in that price column, we'd want to go back to people who know a little bit more about this data and ask why. Why are there separate categories? Why are there different costs or prices? So we've got a few things that we could do to deal with this. First thing, we could manually drop the duplicated rows. Our data frame is small enough to do that, but with a larger data frame, we might have a bigger job and we may want to avoid this. Another thing with dropping duplicated rows is we've got to make sure that we're not accidentally deleting data. So here, this is just a pricing table, which links items that could be purchased together with their prices. It doesn't make sense to have duplicate rows here. But in other tables, perhaps an order table, it would make sense to have the same item ordered multiple times over some time period. So we need to be worried about that. An alternative to manually dropping the duplicated rows is we can use a function called case when, or R has another function called if else, if you prefer, to override the values in some cells. And there are other things that we could do, but these, there are actually just two approaches that I've discussed here, and they're shown below. So here's how you would filter out the duplicated rows. We can start with the products data frame. We can filter. So we've talked about filter as a function. Filter allows us to see only the rows that we're interested in. We haven't used this functionality before, but there's this operator %in%, which allows us to ask whether an object or an item belongs to a list of values. So the list of values here we're passing is outdoor furniture with the capital F on furniture, and then nursery furniture with those misspellings. And so what I'm asking here is, are the items in my row in the list outdoor furniture or nursery furniture? And really this exclamation point on the outside negates that. So what this is saying is, give me all the rows where it is not the case that the items are outdoor furniture or nursery furniture. And so those rows should be missing now. All we're doing again with cable and cable styling is that nice formatting. So what we should see when we run this line or this chunk of code, this chain of commands, is the price of the products table, but we shouldn't see these last two rows. They're the two rows that we wanted to get rid of. Let's see if that's the case. And so here we see the products table. And again, those duplicated entries are not being shown. So perfect, we've achieved our objective. One thing again to be careful of though is this data frame that we've printed out has 1, 2, 3, 4, 5 rows. But if we look at the products table, it still has those 7 observations. So we haven't really gotten rid of them because we've just asked R to take the products table, filter out those the rows, and then show me the result and do it in a pretty format. We'll talk about how to make that change permanent shortly. The other thing we could do is we could use case when to overwrite the offending values and then to filter to distinct rows. I prefer this method. It seems a little bit more foolproof or a little bit safer to use. So what we'll do here is we'll take the products data frame and we'll pipe it into that mutate command. Mutate allows us to add new columns or to change existing columns. So I'm going to change the items column. We can see here the items column. And what I want to do is I want to take different options depending on what the current state of the items column is. So if the items column lists the value outdoor furniture with that capital F, then the way case when works is I use the tilde to describe how I want to replace that value in the items column, right? So I'm replacing the entry in that items column. I want to replace it with outdoor furniture with a lowercase f. So again, aligning the categories. If that's not the case, then I'm going to flow down in this list. So if the items column lists nursery furniture with those misspellings and the capital F on furniture, then let's, in the items column, write nursery furniture spelled correctly and with the lowercase f. So all of this is kind of overwriting our items column. Then, if it's not the case that the items column had outdoor furniture with the capital F or nursery furniture with those misspellings, in all other cases, so for everything else, let's just leave the items column as it was. So this mutate line will change the items column, and really it's going to just take 2 actions. If I have outdoor furniture with a capital F, I'm going to replace it with outdoor furniture with a lowercase f. And if I have nursery furniture with those misspellings, I'm going to replace nursery furniture so that it's spelled correctly and again has the lowercase f on furniture. Once we do that, so one thing I really like actually about pipes that we haven't used so far is there's an ability for us to break a chain of commands at a pipe so that we can see how our data is being changed as we move through a pipeline or a chain of code. So I'm going to break my pipe here and just run products piped into this mutate command so that we can see what actually happened. So what actually happened here is outdoor furniture, where we had that capital F, has been replaced with the lowercase f, outdoor furniture, that was over here. And then nursery furniture, that last line in this table, has been changed so that it's spelled correctly and again has a lowercase f instead of a capital F. There's no need anymore, though, to have 2 rows for outdoor furniture. Again, they're duplicated, and also 2 rows for nursery furniture. They're duplicated in terms of item name and price, both of them. So what we'll do is we'll pipe the result of mutating that items column into distinct. Distinct will take your data frame and just remove any duplicated rows. So we can see that. So now it's no longer the case that outdoor furniture occurs twice, and also furniture does not occur twice either. They both occur exactly one time. And again, cable and cable styling just print out a table in nice format. And we've added the striped row coloring, and then the ability to kind of hover your mouse over and track which row of your table you're on. All right, so there are 2 ways to fix typos essentially in data and to filter down to distinct rows. But again, we haven't actually changed the underlying products data frame. All we've done is temporarily solved our problem, but then The problem is back, actually. If we look at the products data frame, we see that nursery furniture with those misspellings is still here, and outdoor furniture with the capital F is still here. The reason that's the case is because we haven't updated the data frame. We've just asked for the data frame to be printed out, right? Mutate the column, filter down to just distinct rows, and then show me the results in a pretty format. What we can do instead is we can take our transformed data frame, so that code that we used to make these changes, and then we can overwrite the products data frame. So what I'll do is just type products. I like to use the arrows like we said in class, but if you prefer equal signs, you can use an equal sign there just the same. What this says is take the products data frame, mutate that column, so make the changes to the items column, and then filter down to distinct rows. And now we're going to take the result and store it in a box labeled products. So we already have a box labeled products in the warehouse. What R is going to do is replace that box. And so here we'll overwrite the data frame. Nothing gets printed out, but if you look at products now, we only have 5 observations rather than the 7 that we started with. So I'm going to grab cable and cable styling so that everything's printed out nicely. And I'm going to take the new products data frame and pipe it into cable and cable styling so that we can see here's the new products data frame. We've made changes to that data frame in R so that now the duplicates are not there, the misspellings are not there, and we're good to go. So again, there's a look at how you might deal with some what did we call these? We called them inconsistent data recording issues. So there can be anything from misspellings to categories being mislabeled, or maybe you want to regroup some categories in a different way. Let's move on to the second challenge that we might see. The second challenge is unexpected data types. So one thing we might take a look at is back to the products data frame. Now products doesn't have those extra rows anymore, but if we look at, let's say, glimpse on products, we see that items is a character variable. That's just a string. R is not treating that as numeric. It's perhaps categorical, but R is not wasting any memory trying to think of it that way. It's just a string right now. If we look at the prices column, though, it's also a character variable. Prices is something like it might make sense to multiply by a value or take an average of. And if it's stored as a string, we can't do those things. The reason it's being stored as a string right now is because the prices have these dollar signs in them. So I'm going to bring back the pretty table. The prices have these dollar signs in them. That's going to automatically trip that column to become a string column or a character column. And they also have commas separating thousands places. And so that's also going to cause issues for us. We need to get rid of those. So what we'll do is we'll use a function called string replace. So that will take a look at string values. We can search for characters or patterns within them and replace those patterns with a new value. So what we'll do here is we'll take the products data frame and we're going to mutate a column. So mutate, again, remember, means we can add a new column to the data frame, or we can change an existing one. We'll start by changing the prices column by replacing all of the dollar signs. Dollar sign is a special character in R, so we'll have to escape it to tell R that we really want to match a dollar sign. The way we escape it is with a double backslash. And we're saying here that we want to replace any dollar signs we see with nothing. What I'm going to do is I'm going to break my code for a second, because I'd like to really see just what happens when we mutate the prices column one time. In fact, I'm going to edit the code in here a little bit. So Let's just see what happens when we mutate the prices column once. I'm going to put this all on one line, sorry. And so now you can see prices no longer has the dollar signs, which is great. So we're closer to being able to convert this to a numeric column. We still, though, have the comma in the beds row where the price is over $1,000. So we need to, again, mutate the prices. So the code as I had originally written it would work. You can mutate this all in one call to mutate. But I think for us, for right now, it may make sense to use mutate separately a few times as we're getting used to the code. So again, I'm going to take the products data frame. I'm going to pipe it into mutate. That first call to mutate, I'm going to get rid of the dollar signs. The second call to mutate, again, I'm going to look at the prices column and change it. I'm going to use string replace to search for a comma within that prices column. And anywhere I see that comma, I'm going to replace it again with nothing. So after running this code, we should have no dollar signs and no commas, which is nice. You'll notice, though, that the prices column is still a character column. It's still being treated as a string. So let's mutate that column one more time. And again, we'll just take the existing code. All we've done is taken the single call to mutate that as it was written in the original notebook and split it up to 3 separate calls to mutate, which there's no problem doing that. We're going to take the prices column. So here it is. We're changing that column using the mutate function. And what we're going to do is instead of the original prices column, put the prices back there, but change them to numeric values using as.numeric. And if we run this, we'll have prices, and now prices is listed as a double instead of a character, which means it's numeric, and we can perform arithmetic operations with this column now, which is really nice. So now we can pipe this back into table if we want to get really nice output. What I'm going to do is just notice that, hey, if we ask for the contents of the products column, again, notice we didn't change it. So let's change that column permanently using the arrow operator or the equal sign, whatever you prefer. We're not going to store the result of cable in there. Remember, cable is just formatting our table. So we'll take products, we'll mutate it using the 3-step mutate that we did to remove the dollar sign, remove the comma, and change to numeric value. And now if we want, we can pipe products into cable and we have those nice numeric values. Remember, we got that now because we've stored the result of our mutation into the products data frame. So we actually made the changes to that data frame now. All right, so there's, again, changing data types. We showed how to remove offending characters like dollar signs and commas. We also showed how to change the data type of a column using as.numeric. If you had a numeric column and you wanted to change it to a character for some reason, you could do that with as.character. And there are some other as. functions that are sometimes useful as well. So let's move on again to our third challenge. We might have a multivariable column. We'll switch the data frame that we're looking at for now. We'll look at the client's data frame and notice that the name column has a last name, comma, first name. So perhaps we want a first name column and a last name column, not just a name column. And let's see how we might deal with that. So there's a function in R called separate, which we can use to take a single column and break it up into multiple columns. So what we can do is we can take that client's data frame, we can pipe it into the separate function. The column that we want to separate is the name column. We want to separate name into 2 columns. The first column is going to be called last_name. The second column is going to be called first underscore name. And the separator we'll use to identify where the column should be split is the comma with the space after it. So again, what we're doing here is we're looking at the name column. We've noticed that last name and first name are separated by a comma and space. Last name comes first name comes second. So if we separate over that comma and space, we'll get two pieces, the last name, then the first name. And so we're using that idea in this command. Again, what I'm going to do is I'm going to break off cable, and I'm going to overwrite the client's data frame here. That way we're making permanent changes to the client's data frame. So we ran that code that split the columns, the name column into two columns, and we can see that if we pipe this now into clients, we can see that original name column is gone and it's been replaced by last name and first name. So we can use separate to break a column across a separator. So we used the separator comma. There was one comma. We used actually a comma and followed by a space. There was one instance of that in each row of our data frame, which allowed this separate to work nicely. We had a piece to the left of that separator. We called that the last name. And we had a piece to the right of the separator. We called that, the first name. And we got a new data frame, which was, again, a little bit more detailed. Instead of just having a name column, we have access now to the last name and first name of the client. All right, so the fourth challenge, we're not going to deal with this a whole lot, but it is worth knowing about. There's something called wide format data and long format data. Tidy data is the type of data that we're going to be most often interested in working with. Tidy data satisfies a few properties. So every column should be a measured variable in a data frame. And then each row should correspond to a single record or an observational unit. Data's in wide format if columns aren't necessarily measured variables. Perhaps the columns are a variable themselves. So let's take a look at the historical purchases data frame. That's a data frame that's in wide format. I have a client ID, then I have a year, and then I have a number of purchases that they've made during that year. So for 2018, client one made 833,875 purchases. These are wholesale purchases, purchasers, I'm sure. Client one in 2019 had a little bit of a down year, 791,600 units. It looks like they're trending downwards actually as the years go along. So they're purchasing less. What we really want instead of a data frame in this format, though, is I can't really, like 2018, sorry, is not a variable that I can measure on client one. Neither is 2019. I can't measure 2019 on client 1, 2, 3, or 4. Actually, these column headings are values or levels of a hidden variable called year. What I'd really like to have is a client ID column, a year column, and then next to that, a purchase quantity column or something like this. So I'd have not just one row corresponding to client one, I'd have one row corresponding to client one in 2018, another row corresponding to client one in 2019, and then 2020 and 2021. So in all, we'd have 4 rows corresponding to client one, which would make this data frame much longer, right? Instead of 1 row, I'm going to have 4 for each of these clients. This is a wide format data frame. We're going to convert it to a long format, again, because instead of having 1 row for each client, we're now going to have multiple. So what we're going to do is we're going to use a function called pivot longer. I'm going to bring back the historical purchases data frame just so we can see it. So there it is. What we'd like to do is we'd like to keep client ID fixed. That should stay where it is. we'd like to create a year column out of the names of these existing columns. And then the values that are there underneath these years should be a total purchases number. And so what we're doing is we're taking the historical purchases data frame. We're going to pivot it so that it becomes longer. You can kind of visualize this by like putting a pin on client ID and then taking the remaining columns and then turning them downwards. And then kind of expanding the client IDs so that I'm going to get a row for client. I'm going to get multiple rows for client ID 1. I'm going to get 4 of them here because I'm pivoting 4 columns down next to it. So I'll get one row for 2018, 2019, 2020, and 2021. So this minus client ID is saying I don't want to pivot client ID. I want to leave that where it is. You can leave multiple columns in their positions. You don't have to pivot all except one column. All of the remaining columns, their column names will be converted. They'll be filled in under a new column. So the 4 column names corresponding to years are going to belong to a new column, which we're labeling year. That's what year in quotes is doing here. And then the values underneath those old columns, so the values underneath 2018, 2019, 2020, and 2021 will go to another new column. That new column will be called total purchases. So let's take a look at what this looks like. So again, we've got no longer just one row for client ID 1. We've got 1, 2, 3, 4 rows, one for each of the years in our data frame. We've also got this new total purchases column where that client 1's total purchases have just, again, kind of been pivoted across. So we took those values and we kind of rotated them downwards. It's nice when the name of a function kind of matches what it actually does. Again, let's take this data frame. You'll notice right now we haven't actually changed the historical purchases data frame. We just asked for a temporary change. Take the historical purchases data frame, pivot it, take the header, and then show it to me in a nice format. So what we'll do is let's overwrite that historical purchases data frame. We're going to not use the cable pieces because, again, the cable parts are only designed for formatting. We're also not going to use head because if you remember, head takes and shows us only the first 5 rows of the data frame. So what this would do is it would store only the first 5 rows of that pivoted data frame in historical purchases, obliterating all of the other data that's in there. We don't want that to happen. So here we go. Let's take the historical purchases and just pivot it so that those year columns get swung down into a new column called year, and then the values in the data frame all belong to a new single column called total purchases. What we'll do now, just to see that the change has been made, is let's pipe our new historical purchases data frame that's been overwritten into the head function, into cable and cable styling. And we should be able to see, yep, there it is. The changes have been made and they've been made permanently. So now you see that in historical purchases, there are 40 observations of 3 variables, whereas before there were far fewer observations, probably 10, and there were 5 variables there, one for the client ID and then one for each of the years. All right, so our data frame truly has become longer. It has more observations now. Just so that you can see how pivot wider works, one thing, yeah. So if we take a look at the historical purchases data frame, you'll notice that year right now is a character variable. Perhaps we would want year to be numeric. So we can mutate that column if we'd like. So mutate year equals as.numeric year. And again, let's make that change permanent. Historical purchases. So again, I'm mutating that column to become a numeric column and then overwriting the data. And historical purchases, if we print that out now, year is a double now. And so we could do operations with that year variable if we'd like to. Okay, great. What I'm going to do now, so I'm just going to get rid of this code chunk because we've done all of that up above. So I'm just going to comment this out. And again, just so you can see how pivot wider works, we don't really have a use case for it here. But if you had long format data, so like we have now in the historical purchases data frame, we can pivot that data frame back to wide format if we would like. So some of these, I'm going to have to update some of this code because we overwrote the historical purchases data. There's no need to pivot it to longer anymore or to change year to a numeric value variable. So those have been done earlier. I'm just going to comment them out. A pipe will flow through comments. So I can pipe, it will come down to pivot wider. So for pivot wider now, I want to do the opposite of what pivot longer did. I'm going to take ID columns. So these are columns that I want to keep fixed. Maybe I want to keep year fixed. And I want client ID to now be the column names. So I get for each year a total purchases belonging to each client through this. So let's see how that works. Perfect. So now I have a year column, and I have for each of the clients in my data frame, 1 through 9, I've got their total purchases for that year. So pivot longer and pivot wider can be used to essentially undo one another. We didn't really undo what we did with pivot longer here. We just changed the shape of the data. We changed what those columns corresponded to. Originally, the columns were the years, but now it's the case that the clients are those columns. Okay, moving between wide and long formats is actually a pretty useful skill. It's pretty commonly the case that we want to move from a wide format to a long format. So pivot longer is a function you'll get familiar with if you like data science and you want to do more analytics or modeling. I use pivot longer and pivot wider quite a bit in just displaying summary tables. Sometimes tables are easier to digest when they're in a wide format than they are in a long format. And so you'll see me throughout the semester using pivot wider or pivot longer in those use cases as well. Okay, let's do, I think this is the last item in this notebook. Yeah, we get a summary soon. So the last really common data concern or issue, if you want to call it that, is that it can often be the case that we have data spread across multiple tables. There's really good reason for this. It's great database design strategy to store it's called normalize your data or your database so that you're only storing or hard coding values once in one table rather than across multiple tables. We can always use joins if you've used SQL before to build up more complex tables from these much more simple tables. There's space saving advantage here, but then there's also an advantage due to reduced redundancy. If a client updates their phone number and we have just a giant table that includes clients, their contact information, and their order, and it's repeated every time they make a new order, then we've got to update their phone number in every instance that that client made an order. If instead I have just a table with client contact information, I can update that client's phone number just once in that table and save lots of time and effort. So let's take a look at a few of our tables. We've got orders, we've got clients, and we've got products. So products has the prices of the items in it. Clients has client name and contact phone number in it. And orders has client ID, product, and quantity. So it's perhaps the case that we'd like to take this orders data frame and add in our client name so that we know who's making an order and how to contact them with a phone number. And perhaps we also want to add in the price per unit. So this client one ordered outdoor furniture. We want to be able to add in the prices so that we could multiply quantity by price to get a total dollar value for each of these orders. So let's see what we can do there. What we're going to do is we're going to use joins. We're going to use left join. It's a join that I've been able to get very far with. In fact, I use left join almost exclusively in my work. So it's a good one to start with. We're going to begin with the orders table. So just as a reminder, so I'm going to just print out our tables so that we can see them. So here's the head of the orders table. So orders has client ID, the product that they ordered, and the quantity that they ordered it in. We're going to add the columns for a client's name and phone number by joining the clients table onto the orders table. So let's see what that looks like. So here's the clients table. So I have client ID here, last name, first name, and phone number. Client ID is in both tables. So once I see that client ID 9 has made the order in the third row, what I'd like to do is in that third row, add in, oops, let's see if I can see all the clients. Add in Jacob Shell and the phone number 332-722-4831 onto that row in the orders table. That way I know who made the order and how to contact them. Once we've done that, let's also join in the products data frame. The products data frame has the product name and the price for the product. So we're just going to add in the prices for the products that the person purchased by joining that data frame on. Once we've done all that, then we'll mutate a new column to compute the total dollar value for each order. And again, this is just talking about there's lots of different types of joins that we can make, but what I find that I usually want is called a left join. Left join just means I'm going to start with the table to the left of my join. So orders here occurs before my join. So orders is the starting table. And then I'm going to join on the client's data frame. Because orders and clients share only a single column, so here's the orders data frame. It's got client ID. Here's the client's data frame. It also has client ID, and the two tables share no other columns. We don't need to define the columns that we're trying to join by. I've broken my pipe here so that we're just going to take the orders data frame and join on the client's data. So let's see what happens when we run that. So here we get the orders data frame, client ID, product, quantity. But if we scroll to the right, we also get the last name of the client, the first name of the client, and their phone number. Perfect. And if you check through, you'll see that here where we had listed tables and desks under client ID 9, we should have Jacob Shell. perfect, because Jacob was client ID 9, and there's their phone number. You can check through the rest to ensure that this worked if you like. But what we looked up was we matched the client IDs on that client table to do this. So we can see how that first left join worked. I got a wider, well, not really a wider table. I got a table with more variables in it. I added in last name, first name, and phone number for each of the clients. Now I can continue joining onto that if I want. So I can pipe the result of that first join with the extra variables into another left join. So I'm going to continue adding columns on to my table. I'm going to add the products table here. So I'm going to left join the products table, which again, remember, just contain the product name and the cost for that product. But because those two tables don't share a column, so here's the orders. I had a product column, and in the products data frame, I don't have a product column, I have an items column. But the levels underneath these two columns, the observed values, they're the same. I want to make matches on those two columns. What we can do is use this by argument to say the columns I want to join on are that product from the table on the left, from the orders table, is the same as items in the products table. And so we've defined the two columns that R should look at in making this join. Let's see what happens. So now we've got our orders data frame. So the client ID, the product that they ordered, the quantity that they ordered as well, and the last name, first name, and phone number for the client who ordered it, and also the price for the product that they ordered. So if you remember way back from the beginning, the price for outdoor furniture was $675. And so we've joined that information onto this table, which is great. The only thing we haven't done now is we said that we were going to also, where was this? We were going to mutate somewhere. Yeah, we're going to use mutate to compute the total dollar value for each order. We didn't do that yet, so let's do it. So we started with the orders data frame. We added in new columns by joining the client's data frame, which added last name, first name, and phone number. We joined again the products data frame onto this, the result of our first left join. We matched the product column in the existing data frame. So that's this one that we had after making that first join. So we looked at the product column, and in the products data frame, the column corresponding to products wasn't called product. It was called items. And so that's what this is doing, is we're saying the column that we want to join by is product in the table on the left, and that's the same as items in the table on the right. So let's take this and let's mutate. Let's call this new column total value, and it's going to be, well, before we do that, let's take a look at the data frame we're working with and see what the columns are called. So we have quantity and we have prices. So we're going to multiply quantity by prices to build this new total value column. So multiply quantity times prices. And let's see what that gets us to. So we have a new data frame again. If we scroll all the way off to the right, we have a total value column. Total value is the price times the quantity that was purchased. So if I multiply, if we remember, the quantity in that first row was 2. 2 times 675 gets us $1,350, which is the total value for that order. All right, so there it is. I'm just going to reconnect my pipeline, pipe the result into head, and then cable and cable styling to get a nicely formatted table in our notebook output. Here it is. And so there's everything. So we tackled a few common problems when working with data. We saw what happens when you have inconsistency in data recording, so some typos perhaps, or misspellings. We also saw what can happen when we saw what can happen when you have data recording issues. We saw also um, what we can do when we have unexpected data types. So we saw that the price column had was stored as a character, and the reason for that was because of the dollar signs and because of the commas present in that column. We removed them using a function called string replace, and we converted the resulting column back to numeric using as.numeric. We also saw how to deal with multivariable columns. We had a function called separate to deal with that. We had to find a character in that column that indicated where the first variable ended and the second variable began. That separator had to be the same in every row of our data frame. We also saw how to switch between wide format and long format data. This is a useful technique for anything from actual data issues. So we may actually need to convert to long format before we can do data visualization or build models. But it also can be a really useful technique for just displaying data and information in a nice readable format. Sometimes wide data is much more easily consumed by readers and viewers. And then we saw how to use joins, in particular left join, to deal with the case where you have data spread across multiple tables, and so that you can aggregate it all back together. The notebook ends with a summary section. Identifies the functions that we used, why we use them, what their use cases are. And so I hope you enjoyed this video and found it helpful. You'll have a homework assignment to go along with it, but as usual, please ask questions. You're not expected to be an expert after just watching this video and going through this notebook. Thanks, everyone. Have a great day. Talk to you soon. Bye.